All right, so in number 8, we're given that for x greater than or equal to 1, the continuous function g is decreasing in positive, and a portion of the graph g is shown. We're then told that for some series a sub n is defined as g of n, and we're told that g of x, when integrated from 1 to infinity, converges to 8. Which of the following could be true? So this is definitely talking about the integral test. Okay, so this is a clever way to ask the integral test. Um, so recall that the rules of the integral test are that if that function g is decreasing in positive, and if the integral converges, then we can conclude that the series also converges. So we can definitely knock this out, because what we know is by the integral test, we know that that a sub n converges. Where it gets tricky then is figuring out what we can interpret uh, this value to be, because they're not just asking does it converge, they're saying it could converge, and this isn't necessarily it's not giving us the value, but it's asking us the logic of what it could converge to. And unfortunately, to figure this out, you really have to make a mental leap. So the idea is, if you picture what would happen if you did the sum like this, right? So essentially the sum, uh, it uses natural numbers, right? So like if you picture this way, when we're doing an integral, right, of some like g of x dx, right? These are infinitely skinny boxes, right? These are essentially infinitely skinny rectangles that we're using to approximate an area, right? So like we're saying that we're adding up infinitely skinny rectangles to approximate area. That's why we used Riemann sums when we were working on finding integrals. But because these are natural numbers, they go by ones, right? Like it goes n is 1 and then 2 and then 3. Like there is no dx. Like the change in n is always a 1. So essentially what you're looking at is you're looking at uh, an approximation that looks like this. So the short version is that like this Riemann sum is going to look like this, meaning it is always going to be physically higher than the curve. So if the curve converges to 8, then the approximation is going to have to be a higher number than that, and it's going to have to converge to 10, because 8 is not higher than 8, right? 8 is equal to 8, right? 6 is actually smaller than 8, which is the opposite of what would be happening. So in this case, my a sub n has to converge to a number bigger than 8. It literally just has to be a number larger than the 8 that is here. The only option that was larger than 8 is C, which is that a sub n, when you sum from 1 to infinity, will sum to 10. Again, it's not saying that it is summing to 10. It's saying which of the following is even a possibility, and the only one that is here is 10. And that's really a tricky question, because it's not a way that you see the integral test applied all the time.